round 7 of random LeetCode under an hour. I know last round the microphone was really bad. I did say some stuff last round, so I was going to repeat that. Um, Biggest thing, as you can see here, the difficulty is now covered. I said she had to wrote a quick web extension for that. The tutorial of how to do that, if you want to make your own, is on the YouTube channel. So check that out if you want to. What else was I going to say? Oh, also, I've noticed that one big factor limiting me right now to finishing the problems is that I can't seem to type fast enough. So I've been working on that on my own time. And let me know in the comments if you guys wanted to see like a video related to like my typing speed improvements. So yeah, anyway, let's get right into it. Randomize. Okay, done. Come on, really? There we go. Okay, design underground system. Underground railway systems keeping track of customer travel times between different stations. They are using this data to calculate the average time it takes to travel from one station to another. Oh, they will wait for like 10 seconds so that like it's fair. Not that I think 10 seconds will matter. I don't think I should them switching solutions that fast, but okay. Void. We'll check in. Wait. Average time it takes to travel from one station to another. Okay. Implement the class. Okay. That's why I should go. I might switch to Java for this. I'm not. We'll see this. The customer with the card ID equals ID. Checks in at the station. Position name at time t. That's this one. Okay. Customer can only be checked into at one place at a time. Customer ID checks that station name at time t. Which is the average time it takes to travel from the start station to end station. Average time complete from all previous traveling times from start station to end station. That happened directly. The directly is important. Check in start station, check out end station. Time it takes to travel from start station to end station may be different. Time it takes from end station to start station. Okay. So order matters. There'll be at least one customer who's traveled from blah blah when before you call it. May assume all calls check in, check out are consistent. Someone checks in at time T1, then checks out time T1. Okay. Okay. Doesn't seem too bad. Let's look at the input and malloc things off there. So this is what's going to be called ID station. Okay, so let's start from here. Self. Okay, let's think about what we need. Okay, I need some sort of hash map. So okay, I need to store all the paths from station X to station Y, and that needs to be unique. So what we're going to do is we're going to say paths with a hash map. Right, self.paths. Click on it. Reference this later. Essentially, this is what this is going to be. This is going to be from. The key is going to be station X, comma station Y, and then the value will be the average time given what we have currently, given the current values of X and Y. Um, and then we need somehow a way to check in who's checked in where. So I think we'll just do another dictionary. Checked in to, I need to know where they checked in and where they checked out. So I only need to know where they checked in because when they check out, I'll have the values available, so no point storing that. So we'll do another dict, and then we'll just make it key is key would be the time. No, the ID. Obviously, key's ID. The value would be the time they checked in, or let's do station and time. Station, then the time they checked in. Right? Yeah. Yeah. Okay. So they check in. So that means we say okay, self dot check in ID. Um, if self-determined if ID in cell dot check dot value of dot keys. So if this person has been checked in before or has been on a trip before, then we just update where they checked in this time. So checked in ID. ID is a function. I guess that's interesting. I wonder why. Okay, I'm worried about that highlighting. I really wouldn't know how to fix it. Other than I guess changing the variable. Anyway, we'll see what happens. Check in ID is equal to the station, the time. So tuple station name comma space comma t. T is an int, which is nice. Else, same thing. I know they said default, and I know I said I would look it up, but that's I forgot to, unfortunately. Now for checkout, this is where the actual math comes in. I was calculating the paths, so you may assume all of them are consistent. So I don't have to check if they're already in self.checked in, because they should be checked in already according to, yeah. So what I should do is, is there a pop for dictionaries? I don't know. Regardless, it'd be more efficient to do a pop, because I don't want like to persist the data values, because obviously the hash table will be worse. But I don't know if there's a method for that for Python dictionaries. Let me think. I think it's pop something. Is it remove? Or I just mm, I think it is pop. I'm gonna try pop. Let's see. Self dot checked in dot pop. Then that means this. Okay. I don't need this because if you ever check in again when you're already checked in, that should cause an error. Um, I would throw an error here if I was actually coding, but it's fine. I guess I shouldn't leave an open else branch. So this else should never happen. Um, Again, if statement doesn't make sense here. ID should always exist. We'll leave that. Always exist. Wait. Okay. Always not exist. Okay. That sounds good to me. Self-checked-in.pop. The ID. And then we get the station, or we'll call it the start station. Space. Start time. Equal to that. And then we set self dot paths. Okay, this is where if matters. If start station, concept station name. Let's double in keys. It might be a tuple without the actual value here. I'm not sure. But yeah. Self dot path dot keys. Path for this. Okay. Then we just gotta do self dot path dot path, and then throw this in here. Okay, we'll just actually define it. I don't want to be copy pasting code everywhere. That could be incorrect. Equal to. Oh, I need to store the number of paths we have. I'll just call it the divisor. So we just gotta do the, and then for the new one, we have to just do the old average times the divisor plus the new difference, which would be t minus start time, all divided by all divided by average plus 1. And that is the new average. Then you have to comma space average plus 1. A bit confusing, yes, but I can clean it up later. Else, if this path hasn't been done before, then we just gotta say, hey, solve for that path equal to just the difference in time and 1. That looks right to me. Get average time. So I just say return. I haven't added any return statements, but it doesn't matter. They're all returning none. Return self dot add, just for clarity's sake, and also because of this whole tuple thing that I'm not very sure about. I'm pretty sure this is going to error, but I think the tuple converter is only for list. Pretty sure it's going to error out, but we'll see what happens. Some size. Yeah, should error theoretically. Yeah, yeah, at most one argument that would take out. So we'll just remove this, remove this, should do that, and then run. Oh, answer. Interesting. Hmm. So no, 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 no. 14. Oh, wait. So it didn't make it. Oh, it's because I have to return it as a time. Return self path is 0. It's the average time. Let's see. 14, 1.69, 1.69, 13. Okay. So clearly something's wrong in the actual calculations. Let's see. would be 11. That's interesting. I would like to understand why. I'm gonna check out. I'm gonna print um, self.paths because that's the only way to debug this right now. All right, let's see here. Okay, so it fails on the first one, right? Because it should now be 1.69 at this point in time. Why is it 13? That doesn't seem right. Um, so it starts at 1, which is fine. And then this is latent water, so latent. That's annoying. I don't like the way the input is. Whatever. Um, okay. Let's see here. So something's wrong when I update the paths here. Is it the average plus 1? Is the parentheses off here? I wouldn't be surprised if the parentheses are off. So let's just fix that. Average is equal to. So, oh yeah, I feel like these parentheses were off. So average times divisor plus 2 minus our time. Here, right? So you add all that, and then you divide by average plus 1. That's the new average. And then we just say, okay, that's the new. Oh, it should be divisor plus 1. That's why. I figured out the problem. There we go. That should return the correct value. I guess I could really just do, yeah, just do that. Just to double check on my parentheses. Yep, average plus 1, and this will be divisor plus 1. Okay, let's run it. Interesting. I didn't expect this. Hmm, really? Oh, did I remove check? Oh, when I think on the checkout, I didn't remove it from check-in. Oh no, I did. Yeah, let's try this. Okay, where's the problem here? This is printing paths. This is the new average. So the problem is the calculation of the latent water average on the second iteration. So I'm going to say right here, I want you to print for me average and divisor, which should be 12 and 1. And then let's also print. Maybe I should have kept the new average thing. There we go. Oh my god, I did it again. That's so annoying. Yeah, it's very easy to point out when you're not paying attention. It's very easy to figure out the error once you don't have like long statements like that. Yeah. Yep, there we go. That makes sense. Let's delete this. I think everything else should be good. Oh, printing. Let's submit it and see what happens. There we go. Solved in 20 minutes. About. Good job.